Hey Ramblers, this video covers chapter 11.3 in our textbook and deals with the area of trapezoids. Now you can probably find the area of a trapezoid now just by breaking it up into parts, usually two triangles and a rectangle. But in this section, in this video, we're going to teach you how to use a formula for the area of trapezoids, as well as using a formula involving the median of a trapezoid. So it's going to be a new vocabulary, median, which is different than the median of a triangle. So please take good notes, pause when you need to, and thanks for watching. When we talk about the area of a trapezoid, like I said, many of you have probably just seen it as two triangles and a rectangle, figured out the area of those three individual pieces and added them up. And that's true, but let's remind ourselves what's going on with a trapezoid. A trapezoid has two parallel sides called bases, and they have two non-parallel sides, which are often referred to as non-parallel sides, or sometimes they're called legs. The legs comes up more in isosceles trapezoids, where they would be congruent. But these two sides, no matter what, will be parallel, and it leads to all different sorts of shapes of trapezoids. You have some that, quite frankly, look like just a rectangle with a triangle next to it. Other kind, they can be very short and squat. They can be really tall and wide. So they come in all different sorts of shapes. Okay, so let's take a look at the derivation of where this area formula for trapezoids comes from. The first thing we're going to do is I'm going to divide the base 1 down here into three parts. The base of the first triangle, the green triangle, I'm going to call X. The base of the blue triangle, I'm going to call Y. And notice that the base of this rectangle is going to be the same as the upper base. That's base 2. So I could think of it as being down here, or we'll just leave it up there for now. Okay, so the sum of the area of this trapezoid is going to equal the area of the green triangle plus the area of the blue triangle plus the area of the rectangle. And if I plug in the values for that, it will be 1/2 the base x times h plus 1/2 y times h, that's the blue triangle, and then b2 times h. That's going to be the area of my rectangle. I'm going to factor this then. As you can see, I've got a 1/2 in each of the terms, and I have an h in each of the terms. So I'll factor it out, and I have 1/2 h times the quantity x plus h plus 2b2. Now the 2b2 comes from when I factor in a 1/2 out of the b squared h, I get 2b2. Alright, so I'm going to rewrite that now as x plus y, and I'm going to break up the two b's, the two b2's, into a b2 and another b2. And why did I do that? Because if you notice from the diagram, base 1 equals x plus y plus that b2 again. So I can rewrite the first three terms as b1, which allows me to rewrite my area formula as 1/2 b1 plus b2. And that's the simplified formula for a trapezoid that you usually see. Now you might get this down in your notes, but all that really matters is that you have this final formula and that you can apply it when you see a trapezoid. Okay, then let's take a look at the other formula. Let's clean this up a bit and introduce you to another definition. And that's going to be a median. Now, you'll recall maybe that a median of a triangle is a line which extends from a vertex to the midpoint of the opposite side. But that's not exactly what the median of a trapezoid is. In a trapezoid, a median is going to reach from the midpoint of one of the non-parallel sides to the midpoint of the opposite non-parallel sides. Oh, there we go. So the median doesn't come from a vertex, it comes from the legs to the other leg, and always at the midpoint. So the median, of course, will be parallel to the two bases, kind of like the midline theorem. All right, now, what's another important aspect or characteristic of the median is that its length is the average of the two bases. So b1 plus b2 over 2 is going to be the length of the median. Make sure that's in your notes. Now, how does that play into the area of a trapezoid? Well, let's take a look then at the formula for the area of a trapezoid when we bring in the median. Because you'll recall that from what we just saw, the area of a trapezoid is 1/2 height times b1 plus b2, or it's sometimes written as b1 plus b2 over 2 times the height. Now, this first part of the formula is just like the length of the median. So I can rewrite the area of a trapezoid equals median times height. Okay, so let's do a quick summary. The two formulas that I want you to know for the area of a trapezoid are 1/2 b1 plus b2 times h, or you can write it as b1 plus b2 over 2 times h. And then the other formula, its total equivalent, is m times h, which is median times h, because the median does equal b1 plus b2 over 2. Okay, that wraps up this video. Got a couple of tutorials for you on some of the tougher problems that come up in this section. But thanks for watching. Make sure you've got everything in your notes. Add these formulas to your formula sheet. So now we have about 6 of them. So let's keep up with the memorizing. Thanks for watching. Okay, number 10 on page 526 can be a tricky problem. Take a minute and look at the given information. In order to find the PQ, I'm going to use the fact that the median equals 14, and I know that that equals PQ plus 18, which is the other base, divided by 2, which means, solving for PQ equals 10. And that's our answer to part A. In part B, they want the height to the base PQ of triangle PQS. So I'm going to take the 10 that I just found in part A and use that as my base PQ. And then I know that the area from the givens is 25. So the area equals 1/2 my base times the height. Solving for h has to equal 5. Okay, in part C, they want the height of the trapezoid. Well, that's the same as B. If the height of the triangle is 5, then the height of the trap also equals 5. Finally, in part D, they ask us to find the area of the trapezoid, which I'm just going to use as median times height. The median, of course, they gave us is 14, and the height we found in part C is 5. 14 times 5 equals 70. Okay, Ramblers, thanks for watching. There's one more tutorial for you to help you out with number 17. Okay, to find the area of the trapezoid in number 17, I see that I've got a 30-degree angle, and hopefully that's making me think to look for some 30, 60, 90 triangles. So I'm going to drop an altitude from this vertex, and that creates, if I draw perpendicular to the opposite base, a 30, 60, 90 triangle. The side opposite the 90-degree angle is 12, so the side opposite the 30-degree angle is going to be my height of my trapezoid, or 6. I think it's a good idea with these to write out the formula that you need to identify the different parts that you're missing from the given. I can see that I was already told the upper base is 5√3, and I just solved for the height. So now all I need is the length of this lower base. So how am I going to find that? Well, I know that this portion, if I solve the right triangle, is going to be 6√3. So now all I need is this remaining other portion. So I'm going to try dropping another altitude outside the trapezoid, creating another 30, 60, 90 triangle. But here, the 60 is the supplement of that 120-degree angle. And so 6 is opposite the 60 degrees. That means opposite the 30 degrees is going to be 2√3. And since I know that since this whole length must be 5√3, as noted above, the remaining portion of the lower base must be 3√3. Okay, so my final area is going to be 1/2 5√3 plus 9 root 3 times 6, which equals 42 root 3. Okay, thanks for watching, Ramblers.